This is lesson 2.1, which is parallel lines. Your I-CAN statement is determine the measures of angles formed when parallel lines are intersected by a transversal. We're on page 67 of your workbook, and you'll see that the very first thing shows you two parallel lines, and we know that they're parallel because of this little arrow here, and they are cut by a transversal. And cut pretty much just means intersected. And we can see that when two parallel lines are intersected by another line, and we call it a transversal, it's just another line, they form 8 angles. And what we're going to learn in this section is how those angles are related. You guys can probably already see some relations from what you know about vertical angles and linear pairs, but we're going to formally learn all of those relations. So on this page of your workbook, I want you to write down these 4 things. We have a postulate, and it's called the same side interior angles. And then we have 3 theorems, the alternate interior angles, the alternate exterior angles, and the corresponding angles. You just heard a lot of words, but essentially interior means between the two parallel lines. So notice how both of those are interior, and they're talking about angles that fall between the two parallel lines. Exterior means outside the two parallel lines. If they are alternate, they're on opposite sides of the transversal. Notice how both of these are on opposite sides of that intersecting line. And if they are same side, then they're on the same side of the intersecting line. Pause and jot down these theorems. Now turn to example 1. Pause and draw this figure, being careful to include the little arrow that tells us that the lines are parallel. If we don't know that the lines are parallel, then we cannot know these things for sure. And what we're going to do in example 1 is we're just going to name the angle pairs based off a certain angle. And so it tells us angle 4. So our first problem is going to be all about angle 4. And we're going to use the theorems and postulate that we just learned about to label any of the angles that are connected to angle 4 through those theorems or postulates. So we actually have 3 different ones, and let's start with the same side interior angle. Same side means same side of this transversal. Interior means between the two lines. So if I'm looking at angle 4 and angle 6 are both same side interior angles. Look how we abbreviate that, because they are on the same side of the transversal, which again is the intersecting line, and they are in the interior of the two parallel lines. So angle 4 and angle 6 are same side interior angles, which as we just learned means they add to be 180 degrees. Angle 4 is actually related to 2 other angles as well. Angle 4 and angle 5 are related because they are alternate, meaning opposite side of the transversal, interior, being between the parallel lines, angles. And alternate interior angles are congruent. So we know that angle 4 is actually congruent to angle 5. And there's one more that angle 4 is related to, and that's angle 8. Angle 4 and angle 8 are corresponding angles. So I'm going to abbreviate that like that. And what corresponding angles really means is if you look at the 4 angles up here and you look at the 4 angles down here, angle 4 and angle 8 are essentially in that same position, and that's why we call them corresponding. And they are also congruent. So what you're going to pause and try to do is look at angle 7 and identify any angle that is connected to angle 7 through the theorems or the postulate we just learned. All right, check it. Angle 7 is connected to angle 3 through corresponding angles. They're essentially the same angle. And angle 7 is connected to angle 1 through the alternate, being opposite side of the transversal, exterior, meaning outside of the two parallel lines theorem. They're alternate exterior angles. And alternate exterior angles are also congruent. All right, let's move on to another example. That one was just naming a bunch of angles and learning how they're connected. Now pause and draw this figure for example 2. I'm sorry they don't give you the figures. But we're going to explore some angle relationships. So, in this example, it tells us that angle 4 is 118 degrees. So we know that angle 4 is 118 degrees. And what we are going to do is we're going to find the measure of every single other angle using these theorems that we know. All right. Well, immediately from a past theorem, we know that if angle 4 is 118 degrees, what must angle 2 be? It must also be 118 degrees. Oops. From the vertical angles theorem. So we'll pull back that one piece of old information. And now let's use the things that we know, that we just learned. If angle 4 is 118 degrees, look at its corresponding angle, angle 8. That means angle 8 is 118 degrees. All right. Well, now we also know alternate, meaning opposite side of the transversal. Oops, I was going to highlight that blue, so all the ones that are 118 are blue. Alternate meaning opposite sides of the transversal. Exterior meaning outside of the parallel. That means angle 6 is also 118 degrees. Which angle 8 and angle 6 are vertical angles, so that kind of makes sense. Those should be the same measure. All right. Well, we also learned the same side interior angle postulate, which is going to help us know that interior angles add to be 180 degrees. So that means angle 3 plus angle 8 should be 180 degrees. Well, if we know that angle 8 is 118, let's solve for angle 3. Angle 3 plus angle 8 equals 180 degrees. We don't know angle 3, but we do know angle 8. And if we solve that, that means angle 3 is equal to 62 degrees. All right, so we now know angle 3. Check. Awesome. Well, through the alternate interior angles, that means that angle 5 is also 62 degrees. And then from vertical angles, we know that then angle 1 must be 62 degrees. And what's vertical of angle 5? Angle 7. So angle 7 must also be 62 degrees. And you can kind of see how all of these angles are related once you actually start putting a measure with it. Honestly, once you figure out one linear pair, like those two add to be 180, once you figure out one of those, you essentially can know every other angle in this relationship. All right, last example. So we're going to actually prove the corresponding angles theorem. I told you guys that proofs weren't going away and we were just getting started with them. So we will continuously be practicing our proofs, and we're going to actually prove the corresponding angles theorem. So when we're proving a theorem, we're trying to state reasons why that theorem is true, which means we have to pretend like we don't know that it's true and use algebra and geometry theorems, other theorems, to prove why it is true. So I'm never going to write the corresponding angles theorem as a reason because I'm trying to prove it's true. AKA right now I'm pretending that I don't know that it's true. But with any proof, our first step in the statements and reasons is always to write the given information. So we are given that M is parallel to N, so that these lines are parallel. We are given that information. We always start with that. And that's actually really important. We have to know that those lines are parallel for any of the theorems or postulates that we just learned to be true. If we don't know that they're parallel, then we can't for sure say that those angles are corresponding or, same side interior. We don't know that if they're not parallel. And that's why we learned those conditional statements. These lines have to be parallel for all those things to be true. All right, our next step, and again, we're trying to get down to the fact that 1 is congruent to 2. And they've given us 3 labeled angles, 1, 2, and 3. So when we're writing a proof, we have to look at the figure and think, what do we know about these things? And I eventually want to prove that angle 1 is congruent to angle 2. But I can't use the corresponding angles theorem because that's what I'm working to prove right now. So we always can just start with things that we can see and identify. What do you guys know about angle 1 and 3? They're a linear pair. And so then we know that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Those are supplementary angles. They're a linear pair. They add to be 180. I'm just going to write supplementary angles. Okay, so it's like, all right, let's think about what we know. I now know that angle 1 and angle 3 equals 180 degrees. Now let's use one of the theorems that we just learned. We can use any theorem besides this one. We can't use corresponding angles, but we can use a bunch of any other ones that are true. So did we just learn a theorem that'll connect angle 3 to angle 2? Do we know anything that'll connect these two? Yes, we do. The same side interior angles postulate. Actually wasn't a theorem, it was a postulate. So what did that same side interior angle postulate tell us about these two angles? It tells us that they add to be 180 degrees. So we also know that the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And that was from the same side interior angles postulate, because they're same side interior angles. This is where you slow down and you think about the algebra. And if you're doing this in your workbook, you're going to run into that thing that says habits of mind. Just work through it in your 2-column proof. Now let's use that algebra. If I know that 1 plus 3 is 180 and 2 plus 3 equals 180, that in our algebra mind means that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. And that is by substitution. We're just going to substitute this for that, and now those two things are equal. All right. Do that algebra. What can you see on both sides that are the same? The measure of angle 3. So if you were to subtract those, they would undo each other, and you'd be left with the measure of angle 1 equals the measure of angle 2, and that's by subtraction. Be careful not to abbreviate substitution and subtraction both as sub, because then that is the same abbreviation and no one will know exactly what you mean. And our very last step should always be what they're asking us to prove. They're asking us to prove that 1 is congruent to 2, and since we just logically determined that their measures are congruent, our very last step is to say that their measures are equal, so then we can say that angle 1 is congruent to angle 2 by the definition of congruent angles. We can't stop here because that's just stating that their measures are the same, and that's not what it asked us to do. It wanted us to prove that they are congruent. But since we know that the measures are the same, and the definition of congruent angles states that if the measures are the same, then the angles are congruent. So that's our very last step, is always what it's asking you to prove. So your first step is always the given in the yellow highlight. And your last step is always what you're trying to prove. And we used logic, algebra, and geometry to make logical statements that lead to this conclusion. It could be a lot of conditional statements if we wanted to write it as a paragraph, but we just don't. We use a column. But we're essentially saying, if these lines are parallel, then these angles are supplementary, and then these angles are same side interior angles, and therefore those angles must be equal to each other. And if we subtract, then we get that the measures are equal. And if the measures are equal, then they're congruent by the definition of congruent angles. We will keep practicing proofs, but this is lesson 2.1.